I'm Dr. Lonnie Love, and I work in the manufacturing demonstration facility at Oak Ridge National Lab. I'm a mechanical engineer. My group and a number of others are working on the next generation of manufacturing, a lot of work in additive manufacturing. This is 3D printing, really targeting instead of for prototyping, but for real manufactured parts. And it really is pretty exciting. It's bringing all of the strengths together. The history of Oak Ridge National Lab is in manufacturing, and we really are kind of getting back to the roots of what the lab does really well by bringing in these huge scientific tools like the spallation neutron source, like the high performance computing, advanced materials, really kind of bringing it to a focus in the manufacturing demonstration facility, and then working closely with companies to help transition it out. One of my favorite that I think is going to be very impactful was we had a neurosurgeon come in that wants to use the additive to help stroke victims. There's 300,000 stroke victims in the U.S. A lot of these patients have paralysis. So by working with them, we're hopefully going to have a product. This company will have a product very soon to help patients that have had paralysis regain capabilities. Not just help them, but help them restore capabilities. Where's this headed? Who knows? That's the beauty of this. Every day we're getting companies in that are interested in the technology at development of new products, companies that make automotive systems, that make aerospace systems, biomedical systems. It really is a real broad brush in terms of making things, manufacturing things. So I think that in the near future you'll see small companies just dotting the East Tennessee area that are a result of the work we're doing, because companies are coming in with ideas and we're helping them to formalize those ideas into products that then they can develop the whole company behind. The big question is what's going to happen if we create all these jobs? Who's going to do it? And that's the other thing that the lab is doing extremely well, is working with high school students, junior high school students, elementary school students, not just trying to encourage them to go into science and engineering and technology, but also looking at manufacturing. The 3D printing, the additive manufacturing gets at the grain of what these kids like. I had 25 students working in the MDF. 3 students came up with an idea, and within 4 weeks, 5 weeks, they had a whole new type of robot. Never seen anything like it in my life. And we ended up having to submit an invention disclosure, and those kids are getting a patent on it. So it really gets to the grain of what these kids can do if you give them a little bit of focus, a lot of leash, give them a lot of freedom, and the right tools. And that's what gets me excited, is seeing the innovation that pours out of these kids, especially when you give them something like the 3D printing, where they can really go straight from an idea to a part, to something tangible. It really is something almost artistic in terms of what they can do. When you look at additive, it's enabling the engineer and the scientist to become an artist. You're not limited to linear things. You don't have to have straight lines. You don't have to have round holes. You can create very organic and beautiful shapes. We need to be able to teach this to the students, and that's what's going to separate us from the rest of the world. Everybody profits, everybody partakes, everybody wins. So it's a real game changer in terms of manufacturing.